Okay, let me have your attention right here. Okay, we are going to have the test on Friday. Since today's a short day, we're going to just do a little test review with this worksheet I gave you. We are going to, most of the questions on your test, or quite a few of them, are going to be explicit or recursive formulas, writing explicit or recursive formulas for linear, quadratic, and exponential. So I'm going to just tell Alyssa a little something right here. Alyssa, if you're listening to this, I'm going to also post this assignment on my webpage as well as this video, so you can download it and print it. All right. Everybody say hi to Alyssa. Hi, Alyssa. All right. Okay, so she's probably laying on a beach somewhere right now, don't you guys think? I mean, where did she go? California. Do we feel sorry for her right now? Okay, no. Okay. We don't feel sorry for you, Alyssa. All right. Huh? Okay, so 159. Okay, there was a mistake on number 1. Should be 159 what? 13. Okay, so we follow the pattern. We figure out. We already know it's linear because it said it's linear. But what is the constant difference between terms? Well, it's not supposed to be 12. That was a typo. So cross out 12, put 13. Okay, what's the constant difference between terms? 4. Now, you guys, when we write an explicit formula for a linear equation, okay, it makes it really easy. You guys, I need all eyes right here. All eyes right here, okay, because some of you don't understand this concept yet. Okay, when we write an explicit formula, by the way, what's the difference between explicit and recursive formula? If you know, raise your hand. I just want to see how many of you know. The difference between explicit and recursive. How many of you are still a little bit cloudy on it? Raise your hand, go like this if you're a little cloudy on it, okay? All right. An explicit formula is a formula like if I'm on this is the first term, second term, third term, fourth term, and fifth term, and so forth. What if I wanted to know the 100th term down here, right? All I would have to do is put 100 in for my variable, and it would tell me what the value of the 100th term is. That's an explicit formula, okay? However, if I want to know the 100th term, could I use a recursive formula to do it? Yes, but what would I have to do? I have to get the 99th term. And to get the 99th, I have to get the 98th. So I'd have to get all the terms clear up to 100 term. I'd have to get every single term to get it. A recursive formula just tells us what the next term in the sequence is. So if you're not sure, everybody write this down. A recursive formula tells us what the next number in the sequence is. If you know that already, or you have it in your notes or you can easily see it, you don't have to worry about writing. But a recursive formula tells us what the next number in the sequence is. An explicit formula tells us whatever term number we want, what the value of whatever term value we want is. So that's what we're going to do right now. We're going to do the explicit first. Now, with linear equations, the most important thing is to find out what the constant difference is. What is the constant difference here? 4. And so my equation is going to be written like this. We're going to write it as f of x equals 4x. Guess whatever the constant difference is. Christian, I know you're good at this, but you're distracting a lot of other people that are trying to listen, okay? Whatever the constant difference is between terms, that's 4 in this case, is what you're going to times x by every single time. And then all you have to do is say, okay, if I put 1 in for x, 4 times 1 is 1, but my value of my first term is 1, what do I have to do? 4 times 1 is 4, and what do I have to do to get the 1? Guys, if I put 1 in, I put this 1 in right here. 4 times 1 is 4. I want 1. What do I have to do? Minus 3. Now we check to see if that works for the second term. I put 2 in. 4 times 2 is 8. 8 minus 3 is 5. I put 3 in. 4 times 3 is 12. Minus 3 is 9, and so forth. Okay, and so we've got an explicit formula. Now, if I want to find the 100th term, 4 times 100 is 400. Minus 3 is 397. So I don't have to find the 99th term to get it, right? That's what an explicit formula does. I want to make sure we understand that. Okay, now, a recursive formula. What's a recursive formula going to do right here? What do we do? So close to this, I can't tell what I'm writing. Recursive. Did I spell that right, you guys? Okay, so in a recursive formula, remember I taught you guys how to use A sub n, sequence notation. You can also use function notation. I don't know. I kind of like, let's just use this, A sub n. A sub n is equal to, how do I do this? A sub n minus 1, because I always have to have the previous term, right? And then what am I going to do to the previous term to get the next term? Add 4. That was the common difference. And so there's my recursive formula. So you always have to remember, recursive formula, you have to have the previous term. And then what is it you're going to do to the previous term to get the next term? You guys think you can do that? Okay, everybody go to number 1 on quadratics. Quadratics. Okay, 5, 8, 13, 20. Okay, on quadratics, we find the first set of differences, which is 3, 5, 7, and we notice there's a pattern there. What are they doing each time? The difference is increasing by 2 each time. So the second set of differences is constant. So we know if the second set of differences is the same number, then we know that it's a quadratic, right? By the way, what would be the next term in this sequence right here? 29, which would give us a difference of 9, which would give us a difference of 2 right there, right? So I just wanted to expand that out one more just so you can see. So the second set of differences is a constant 2. So when that happens, we know it's quadratic. Now let's do the recursive formula first for this one because it's a little bit easier. Well, recursive for a quadratic is quite simple because you do the, what do you always do with a recursive? You always do the second, well, but you got to know what the first term was, right? The previous term. How do you write the previous term? A sub n minus 1, right? Plus, what are we going to add to it? Now, you guys, since the second set of differences is a constant 2, this 2 right here is what we're going to use. This first set of differences is linear, isn't it? We can use that fact to write our next term. And it's just like writing a linear equation. Since the difference between terms is 2, it's going to be 2n, right? Now, if we take the first term, which is 5, right? The first term is 5. Okay, so let's say we're trying to find the second term, 8. So we take the previous term, which is 5, plus 2 times 2 times 2, which is 4, right? You know what? We should do this way. Sorry. It's been a little while since I've done it. So I think we got to find this term right here. Since these are differences of 2 right here. To find the second term, which the value is 5, this 5 right here. Okay. We go to the previous term, which is 3, plus 2 times 2, because we're looking for the second term. 2 times 2 is 4, plus 3 is 7. But we want 5, so we minus 2. Is that going to be right? Oh, yeah, because it's got to be the... Why, Christian? Tell everybody.
If you like trying to find the second term.
Yeah, if you...
Put the previous term in versus 5. You have to put the previous term, which is 5, and then plus the 2n. You're trying to find the second term, so 2 times 2 is 4. 5 plus 4 is 9, and then minus 1.
That's right, that's right. And you guys, it's always going to be minus 1, actually. Like that. No, because this is a recursive formula. If we were finding the quadratic, okay, we're out of time. Hey, you guys, I want you to, if we were looking for an explicit, we would. I want you to try and do all of these problems right here. Even the exponential, even though we didn't get to them, okay?